This meeting is being recorded.
In this next video from chapter 17, we're going to take a look at two sample exercises, sample exercise 12 and 13, both of which will utilize the knowledge that we gained about molar solubility and our solubility product constant in previous videos. So let's take a look at what we're given here. So we're told that the KSP for this lanthanum fluoride is 2 times 10 to the negative 19th. And we're asked to find the solubility in water in moles per liter. So we want to find the molar solubility. All right, so how can we set this up? So these problems, it's usually a good idea to just draw out the solid dissociation. So when we add this to water, we're going to get some lanthanide. I know these are going to be 3+ ions because of the fluoride always being -1. We're going to get, let's space that out. So we're going to get 3 moles of fluoride ions for every 1 mole of lanthanide, for every 1 mole of the compound that we begin with. So our KSP expression then is going to be our concentration of La3+ times our fluoride ion concentration cubed. So using this information, we can plug in what we can call some dummy values here. So we can solve for this variable S for the solubility of lanthanide, and then this solubility is going to be 3 times that. So we're going to plug in a 3S. So we're just going to keep these in mind, that S is going to represent that solubility, 3S will represent my fluoride. So these are from the stoichiometric coefficients. So now I was given my KSP equals 2 times 10 to the negative 19th. I'm going to set that equal to my KSP equation. Since I don't know these concentrations, I'm going to plug in S for my LA, and then we have 3S here. And make sure that the coefficient is also included as an exponent again. So it might seem redundant, but this is the way that we have to set up these equations to get the right answer. So we're going to simplify this here. So when I cube 3S, I'm going to get 27S cubed. So just this portion here. And then I'm going to multiply that by S. So I'm going to get 27S to the 4th power here. So we know this is equal to my 2 times 10 to the 19th. I'm going to divide both sides by 27 initially here. And then after we do that, if we take the 4th root of both sides here, we'll get our final answer. A way to do this, if you're not sure how to enter it in as the 4th root, you can put your 2 times 10 to the negative 19th over 27. You can raise that to the 1 divided by 4 power. So this is to that power. But you have to type in 1 and then divide by 4 to do this way. So either way, you should get this value. So your S is going to be equal to 9 times 10 to the negative 6 molar. So if you didn't get that value, try again or reach out and ask me to help. So we solved for S. This is our solubility. Specifically molar solubility. Let's take a look at sample exercise 13 here, and we'll work through this. So we're given KSP for our silver carbonate is 6.2 to the negative 12, and we're asked what's the solubility. So we have to do something similar. We'll set up our dissociation here. So we get 2 moles of silver ions for every 1 mole of carbonate. When we ionize here, my KSP expression will then be silver squared times carbonate to the 1st power. Then we're going to remember to use that coefficient twice when we set our KSP here equal to my 2S and S. So I'm going to plug in 2S squared, and then S for my concentration of carbonate. My simplified equation now is going to be 4S squared times S or I'm going to have 4s cubed. So since that's equal to this, we're going to divide both sides by 4. And then if you take the cube root, like so, you could raise all this to the 1/3 power, like we did in the last problem, and you should get the same answer for s, whether you take the cube root or raise it to the 1/3 power. So we're going to see that our solubility for this turns out to be, with rounding to 2 sig figs, 1.2 times 10 to the -4 molar.